Logical operators are the backbone of decision-making in programming. They allow you to combine multiple conditions and evaluate them to determine the flow of your code. In Python, we have three primary logical operators: and, or, and not. The AND operator returns true if, and only if, both conditions it connects are true. For instance, 5 is greater than 3 and 10 is less than 20 would evaluate to true because both individual comparisons are true. The OR operator returns true if at least one of the conditions it connects is true. For example, 5 is less than 3 or 10 is less than 20 would evaluate to true because the second comparison is true, even though the first one is false. The NOT operator is a negation operator. It reverses the truth value of the condition it precedes. So not 5 is greater than 3 would evaluate to false because 5 is greater than 3 is true, and the NOT operator flips it to false. These logical operators are essential for constructing complex conditions within your Python programs, allowing you to create sophisticated decision-making logic. Conditional statements are fundamental to programming, enabling your code to make decisions based on certain conditions. Python provides three keywords for this purpose: if, elif, and else. The if statement checks if a condition is true. If it is, the code block indented under the if statement is executed. For instance, if age is greater than or equal to 18, print you are eligible to vote. The elif statement comes after an if statement and provides an additional condition to check if the previous if condition was false. You can have multiple elif statements following an if. For example, if grade is greater than or equal to 90, print A. If grade is greater than or equal to 80, print B. If grade is greater than or equal to 70, print C. The else statement comes after an if and any optional elif statements and provides a code block to execute if none of the preceding conditions were true. For instance, if the number is even, print even number. Else, print odd number. These conditional statements form the basis of decision-making in Python, allowing your programs to respond differently based on varying conditions. Loops are essential for repeating a block of code multiple times. Python's for loop is particularly powerful for iterating over sequences like lists, tuples, strings, and ranges. The basic syntax of a for loop is for item in sequence, code to be repeated. For example, to print numbers from 0 to 4, you would write for I in range 5, print I. Here, range 5 generates a sequence of numbers from 0 to 4, and the loop iterates through them, assigning each value to the variable I in each iteration. You can loop through lists, strings, or any other iterable object. For instance, consider a list named fruits containing apple, banana, and cherry. This code will print each fruit in the fruits list. For loops simplify repetitive tasks, making your code more concise and readable. While loops. While loops offer another way to repeat code in Python. Unlike for loops that iterate a fixed number of times, while loops continue executing as long as a specific condition remains true. The syntax of a while loop is while condition. For instance, to print numbers from 1 to 5, set the initial value of I to 1. In while statement, check the condition if I less than or equal to 5. Print the current value of I, then increment I by 1. In this case, the loop continues as long as the value of I is less than or equal to 5. The increment of I by 1 is crucial in each iteration, eventually making the condition false and terminating the loop. Be cautious with while loops, as an incorrect or incomplete condition can lead to infinite loops that never end. Section 6. Accessing data with loops. Loops are particularly useful for accessing and manipulating data within data structures like lists, sets, tuples, and dictionaries. Lists. Here is a simple example of how to access data in a list using a for loop. Consider a list named MyList containing 5 values. This loop iterates through each element in the list and prints its value multiplied by 2. Now let's see how to access data in a dictionary. Consider a dictionary containing 3 key value pair: name, Alice, age, 30, and city, New York. We can use items function to loop through both keys and values. This loop iterates through the key value pairs of and prints each key value pair. You can apply similar logic to access data within sets and tuples using loops. Nested conditions and loops. In Python, you can nest conditional statements, if, elif, else, within each other or place them inside loops, creating complex logic. In this example, we loop through a list of numbers and print only the even numbers. Similarly, you can nest loops within loops to iterate through multidimensional data structures or perform repetitive tasks within other repetitive tasks. Consider this example to print a multiplication table of 1 to 5. The outer loop is for the row 1 to 5 and the inner loop is for the column 1 to 5 when I is 1. J iterates through 1 to 5 giving the first row and so on. Section 8. Functions and modules. Functions and modules are essential for code organization and reusability. Functions. Functions group a block of code that performs a specific task. You define functions using the keyword def. For example, this is a function to greet a person when her name is input as a parameter. When this function is called with name Alice, it will print hello Alice. This code defines a function that takes a name as input and prints a greeting. Modules. Modules are files containing Python definitions and statements. They allow you to organize your code into reusable components. You can import modules using the keyword import. For example, in order to use the constant pi defined in module math, we have to first import the math module. Another example is to generate a random number. We need to import a module named random. This example generates 5 random numbers between 1 and 10. In the next lecture, we are going to talk about the basics of object-oriented programming, Python classes and objects.